While recently window shopping for watches, I came across an interesting niche of products. Watches leveraging transparency or translucency in their design. I found a number of interesting options from Swatch, Casio, Guess, and Nixon. But upon coming across one particular Hublot, I wasn't just impressed, I was pretty astounded. The design of this Hublot Sapphire is incredible. And so is the price, making it something only most can dream of. But it got me thinking, couldn't I 3D print something similar? While FDM 3D printing has come a long way, it can't quite deliver on fully crystal clear parts. However, resin 3D printed parts can, and a resin 3D printed watch case and band would offer a similar level of translucency, quality, and fidelity. So that's what I want to answer today. Can I design and make a homage of this amazing watch that is both functional and fashionable? TLDR, I think I can.
The first issue to overcome in this project is the resin itself. UV resin is notoriously hazardous. Assuming that there'd be some product out there that had proven skin compatibility, I took to Google to see if I could find anything. Fortunately there was, although the first listing was not too promising, with an extremely exorbitant price tag. Fortunately, the second Google result offered a product which was far more affordable and readily available. Soriatex Blue. With that on order, I then moved to considering what movement I was going to use inside this watch. I looked far and wide for affordable skeletonized mechanical movements that could really lean into the see-through style of the Hublot that I'm trying to mimic. But none were anywhere near the same level as that of the Hublot. So instead, I considered alternative approaches. I knew I wanted this to be an analog watch, so I looked around for what watches had the right aesthetic and that I knew I could deconstruct to integrate into my design. I ended up returning to the Casio G-Shock series, specifically the GA2100s, because there are a number of different colorways you can choose from, and having previous experience in disassembling one, I kind of knew what to expect with the movement inside. Whilst waiting for the watch and resin to arrive, I began work on the design of the band. What I incorporated into the design I think is a rather ingenious print-in-place hinge mechanism for the band links. And as for the clasp mechanism, because I want this to be as quick and easy to put on and take off as possible, I'm going to leverage magnets. It's not going to have any adjustability, but I can size it perfectly for my wrist, so that's not an issue. Getting to a final working band design took a few iterations. Initially the band was a bit too chunky, then I made it a little bit too slim. After getting the aesthetics and feel of the band right, I then moved on to the clasp mechanism and designing in the magnets. The magnets worked okay, but there was a lot of lateral play, with no features stopping the magnets sliding side to side. I added those features to the fourth design, but was unhappy with the amount of retention offered by these magnets. So I sourced some higher quality N52 magnets, and they work like a charm. With my chosen watch also in hand, I can disassemble this and use it to progress the case design for the watch. It doesn't look too bad for a counterfeit. I wasn't willing to throw away around $200 on this should anything go wrong. After many hours in CAD, designing a case that would not only be aesthetically pleasing but also manufacturable, I arrived at this design. Much like the Hublot, this design has visible fasteners on the bezel of the watch, which are used to hold the two-piece clamshell design together.
So after iterating through the band a few times and printing this case, I'm happy to say that I've got a working watch. At least mechanically, I've got a working watch. But looking at this on my wrist, and particularly seeing how it fits on my wrist, leaves a little to be desired. The case and the lug-to-lug distances are much too great, and the watch doesn't have a nice appearance on the wrist. So I reduced the lug-to-lug distance, the watch diameter, and also reduced the height of the lugs down a little bit, so the band would sit a little bit closer to the wrist, and that's where I ended up with this rather sleek looking accidentally marble PLA wristwatch. Looks much better. It feels actually quite a bit better too, because the band is conforming to my whole wrist. So let's see how it turns out in resin. So the resin print didn't go too great. It has some issues with the initial layers, but it still gives me a basis to test and check some of my measurements, like the dimensions I modeled for the crystal, for the bezel, for the movement, check the buttons interface correctly with the buttons on the movement, and just see it in the flesh.
Importantly, I also found out that the tolerances in the design of my band were too tight, as not only did the band fail to be able to articulate, but the magnets wouldn't fit in the end links. That was good learning and easily rectified, and then validated. With Serai's special sauce also now in hand, I can begin printing for real. So while I attempt to print these first parts, and yes, attempt is the right word, let me talk about resin post-processing. Let me explain what's needed to make blue truly skin safe. Typically, UV resin undergoes exposure in a machine. You wash the printed part to remove the excess uncured resin, you let it dry, and then you expose it again to fully harden the resin. However, with blue, the post-processing is a little bit more involved. The same exposure occurs, along with wash, but following that, an ultrasonic clean is required, followed by a baking at 60 degrees. Only then can final curing take place. Off the printer, these first parts were looking great. So whilst those parts undergo a wash, I'll set up my ultrasonic cleaner for the next step in the process. Unfortunately, after removing them from the plate and giving them a thorough clean, I can see I've got some problems. Unfortunately, this blue is particularly prone to overexposure, meaning that curing is happening outside where I want it to, and the holes that I've designed into this model for the fasteners to pass through or thread into are being completely filled with cured resin. Similarly, while the band worked previously, overexposure once again is causing all the links to fuse together. Despite running calibrations, I had a great deal of printing reliability issues with this resin. I tried a multitude of different print orientations, but suffered defects in all of them. I tried slowing things down to an absolute snail's pace, to the point where these parts would take more than a day to print, but would still run into issues. In the end, I decided to print these parts in the least worst position, and compensated for this in the design. So with those issues addressed, I can now proceed with the cleaning, baking and curing of these parts, in preparation for assembly. With all the parts printed, many times over mind you, and the fasteners, crystal, magnets and movement all now in hand, I can begin assembly. The magnets for the clasp mechanism are simply glued in. A bit of CA is more than enough to retain these parts long term. However, when it came to assembling the case, something I feared occurring eventuated. I designed into the case threaded holes into which the fasteners on the face of the case would screw into. However, with the size of these fasteners being only 2mm in diameter, and blue being a resin that errs more towards toughness rather than ultimate strength, meant that these parts were too soft and the holes were getting stripped very quickly. To address this, I went back to the design, added features that I could install typical heat set inserts into, so that I'd have a much more secure and long-lasting mechanical interface between the fasteners and the base of the case. From there, everything went much more smoothly. These typical heat set inserts were simply CA'd in, just like the magnets, and then the crystal could be installed, followed by the movement, the pushes, and then everything sealed up.
Alright, moment of truth. I've made the watch that I said I would make. I'm pretty happy with how it turned out, but how does it look and feel on the wrist? Here we go. Feels good, it's snapping on. Ow. Pinches, because ow, it's a bit short. But wow. Whoa, look at that. That is pretty good. It feels very nice. Conforms very nicely. And I love the end result with how it's, you know, it's not entirely transparent just because of the surface finish from the resin machine, but it looks pretty dang good, I think. Here's some B-roll. Not bad, not bad at all. Now the design for this watch, band and case is going to be on MakerWorld, so check it out there. But don't think that if you don't have a resin 3D printer, you can't make this, because you can actually FDM 3D print it. As you've seen me do through prototyping, I've been able to develop the design such that it can be made on a filament machine. It does print pretty good, it does look pretty good, and it does feel pretty good. The only issue really is with the precision of printing around where the pushes fit. So that'll need a little bit of finessing on the finished print in order to make sure the pushes have clearance to move. But yeah, I think it looks pretty striking, particularly in this marble PLA, which is good in that it also hides a lot of the finer issues with this kind of marble pattern. And all the top surfaces have ironing, so everything comes out extremely smooth and clean, which is really nice. So yeah, check that out, link in the video description, and give it a go yourself. Let me know in the comments below how you think I did creating a homage of that amazing Hublot watch. And until next time, see you later. Bye. The design of this Hublot Big Bang integral, oh my god. The design of this Hublot integral oh my god, and fashionable. TLDR? I think I can. I'm holding up the wrong way. It's pinching. Oh, it's pinching. Ow. Don't pinch. Ow, 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 ow. Let me know how you did, I think. Let me know how you did, I think.